Resume recording. All right. So I made just a few notes. In this unit, you're looking at the Boolean type of variable. Let me actually snap the screen here and here so I can see a little bit better. Okay. Yeah, there we go. So the Boolean type. We haven't used it that much in class yet, but you're going to be using it an awful lot in Unit 3. So it's important that we understand, just kind of do a quick little review of it. The way that we make a Boolean variable is, first of all, Boolean is a type just like int, just like double, except Booleans don't hold numeric values. They hold true or false. It's named after English logician, philosopher George Boole, if you were curious. Nobody ever is, but that's Boolean, and it holds true or false. Even though true and false are words, you would think they're strings, you don't put quotation marks around them. So that's kind of the first thing. Here's an example of making a Boolean variable. Oh, we got another one. All right, another participant enters the fray. Hello, welcome. Welcome to our large group here. All right, so Boolean variables, true or false values. And why are Boolean variables going to be very important? Well, Boolean variables are going to help us make decisions. Like today, you go, is it raining outside? True. And if raining outside is true, I'm going to bring an umbrella with me, for example. You use true or false values to make decisions every single day of your life, every single moment of your life, really. And that's how computers make decisions as well, using these true or false values. So, so that's Boolean variables. They can be true or false. Now, it's not very interesting just to type true or just to type false into one of these variables. Really, we want the computer to evaluate a statement and decide if it's true or false on their own. So to make the computer decide if something is true or false, evaluate it, compute that value on their own, we can use what's called a relational, aka a comparison operator. And these are essentially your inequality symbols that you know from math class. Less than or equal to, greater than or equal to, greater than. And they evaluate to true or false. For example, let me just go ahead and let's print out 5 is greater than 3. I think we can all agree 5 is greater than 3. These operators always kind of reduce down to a true or a false value. So since 5 is greater than 3, I see that true prints out. If I do 5 is less than 3, well, that's not a true statement, so I'll run it again, and now I see false. So anything with these relational operators will evaluate to true or false. It's just how you compare numeric values. You can use them with doubles as well. If you want to do like a greater than or equal to situation, for example, is 5 greater than 5? No, 5 is not greater than 5. If I go, I'm going to give you $5, and you go, well, I'd really like $5. I'd go, what's wrong with you? 5 is not greater than 5, but if I want to do greater than or equal to, I look at the keyboard and notice there's not a greater than or equal to key like I would write it in math class. So to get around that, in Java, you do greater than or equal to like that. It looks like kind of an unhappy face. So now if I go ahead and run that, 5 is equal to 5, so it's going to say true there. Because 5 is not greater than, but it is equal to 5. So 5 greater than or equal to 5 evaluates to true. Similarly, if I do 5 is less than or equal to 5, 5 is less than or equal to 5, so that's true as well. So you can make the computer make all these decisions using those comparison operators, or sometimes they're called relational operators, how one value relates to another. It's just like an inequality in math class. Instead of printing it, I could put it inside of a variable. So for example, I could do something like example 2 is, maybe I want to see if a number is not negative. I could say, is 5 greater than 0? And then I could print out the result of that variable. Is 5 greater than 0? Yes, it is. So true gets stored in example 2 at x2, and then when I print out x2, it says true. If I want to use another variable in the evaluation, maybe I could do something like this. And I could say num is an integer that contains 5. Is the value of num greater than 0? 5 is greater than 0, so in that case, it'll evaluate to true. If I change num to 0, this will evaluate 0 greater than 0. 0 is not greater than 0, so that would be false. And you don't have to name your variables x2 and stuff like that. You could do something like, how about this? Is positive. That's a really common name, really common way to name your Boolean variables, or with is or has or something like that, because it's a true or false value. So if I want to check if num is a positive value, I would say, is num greater than 0? The computer calculates whether that's true or false, stores it in is positive, and then I can print out the result of is positive there. 0 greater than 0, 0 is not a positive number, so I get false there. Lastly, if you want to compare equality, maybe if I want to see if a number is actually 0. To compare equality, you use two equal signs. So if I want to see if this number is exactly equal to 0, I use two equal signs, one after another. I know it's a little bit hard to see there, but there are two equal signs there. And so when I print that out, this is basically saying, is 0, 0? Indeed, it is. And so there's one of those. If you want to see if two values are not equal to one another, like for example, is not 0. There's this special operator. The exclamation point means not in computer programming languages. So if I want to see if a number is not 0, I can put the not in front of the equal sign there. Is not 0. So if I run this code here, is 0 not 0 is kind of the thing that the computer's doing in its head. 0 is not 0, so it's false there. If I put in a number like 5, I think we can all agree 5 is not 0. So in that case, it says true. 5 is not equal to 0. So that is a true statement. So those are kind of the relational operators. They basically evaluate to true or false, and there's 6 of them. There's less than or equal to, greater than or equal to, greater than, equals, and not equals. And if you're wondering, why do we have to use two equal signs to compare equality? Well, if we use one equal sign, Java would be very confused. Java already has an operator that's the single equal sign. It means something totally different. The single equal sign is how we assign a value to a variable. So it's essentially taken. We can't use it again for a different operation entirely. So we use two equal signs for comparing equality. And so that's kind of the Boolean type and relational operators and getting the computer to evaluate that stuff for you. And so I've got a couple more examples on my sheet over here. If I wanted, 50 greater than 30, that would evaluate to true. If I want to use a variable, I could do 30 is less than some num, where supposedly some num is some variable I've created somewhere else in my code. I can compare two variables, by using their variable names. So you can either compare two values, a value and a variable, or you can compare two variables as well. And those relational operators always will return a true or a false for you. Questions there? I was going to run through a quick example that it's like the first example that they have in 3.1. And I'll run through it because I think it's relatively quick here. This is a short program that checks whether or not somebody is eligible to vote, old enough to vote, essentially. And so what's going to happen is you prompt the user, ask them for their age, they type in their age, and then you state whether or not it's true or false that they are greater than or equal to 18 years old. So import the scanner class, make a scanner, prompt them, receive their input, and store it in a variable named age. And then to check if they're old enough to vote, see if age is greater than or equal to 18. Let's test it out. Enter your age, 85, true story. I look younger. I'm old enough to vote in the US. Old enough to vote. So basically the computer evaluates, is 85 greater than or equal to 18? It is, so you're old enough to vote. Maybe too old. I didn't say that. That's not true. If I run it again, maybe the user says they're only 11 years old. Old enough to vote in the US? False. So when it evaluates, is 11 greater than or equal to 18? Not true. You could do other things similar to this, like Boolean, old enough for rated R. How old do you have to be for rated R? Is it 17? How old to watch rated R? 17. Okay. So going back to my thing here, I could do age is greater than or equal to 17 years old. So let's see. Oh, and then I should print it out. Whoops, 1 second. I could do something like old enough to watch rated R. Old enough for rated R. Just concatenate on that Boolean variable there. Let me stop this and run it again. So if you're 17 years old enough to vote? Nope. Old enough to watch rated R? Yeah. You could have another one, like you have to be, I think, 25 to rent a rental car. Old enough to, to rent car. You have to be 25 years or older, so I could do age is greater than or equal to 25. And then, I don't know, I'm just gonna, don't mind me here, I'm just gonna copy this line because I'm being a little bit lazy. Paste it in, didn't work, that's okay, I'll type it faster. Old enough to rent car. And then I can concatenate on old enough to rent car, something like that. So now user runs the program again. If they type in 20, they evaluate all these separately. Is 20 greater than or equal to 18? That's true. Is 20 greater than or equal to 17? That's true. Is 20 greater than or equal to 25? That's false. And that's what you see in the results over there on the right. So that's essentially the Boolean operator using using the relational stuff there. I'm trying to think if there's any other special important ages I can think of. How old are you? How old? Wait, how old to retire? 66 years and 2 months. It's kind of weird. And it will gradually rise to 67 for those born in 1960 or later. What? You're going to keep raising it. You know what it's going to be like? How old I'm going to have to be to retire? I'm going to have to be 1,000,000 years old to retire. I'm never going to see a pension. Are you kidding me? Oh my gosh. Well, let's say they're 67. So let's see, you know, you could put in old enough to retire or something like that, greater than or equal to 67 or whatever. So that's kind of the idea there. I think there's maybe a couple more examples that you walk through. And then there's one last thing I wanted to talk about, and then I'll let you guys go because really 3.1 I think is a short, easy to understand section. Not that you can't ask questions, but to compare strings, do not use equals to compare string equality. This is me making an X with my hands because I don't want you to do it. Here, maybe I'll draw it on my screen as well. Do not use equals. Okay, you get the idea. Don't use equals to compare strings. What do you do? What do you do instead to compare strings? I've got in my notes right here. To compare strings, use dot equals. So as an example, let me go back here. Let me do something like, oh, here you go. Here's an example. Password. Let's say somebody has the password of ABC123. I think that's actually one of the most common passwords, unfortunately, in the world. But it's true. Maybe I make a scanner so that the user can input something, and then I prompt them. I say something like, enter your password, something like that. And then I get string user pdub password. is I'll have the user put it in, something like that. And then I can do something like Boolean correct PW. And if I want to check if what they typed in is equal to their actual, you know what? I'm going to rename this. Why'd you go there? I'm going to rename this actual password. There we go. If I want to check if they're equal, I can do something like actual password dot equals user password. And so that's how you compare strings. Instead of writing equals equals to compare equality like you would do with ints or doubles or other numeric values, use dot equals to compare strings, because it's a method in the string class, which we've spent a lot of time in last unit with dot substring, dot length, dot whatever, dot index of. It's just another method. Dot equals compares strings for equality. And then I could do something like correct, and then I could concatenate on the value of correct password. So let's see if I go ahead and run it here. If they type in ABC124, oops, that's not the correct password. It's false. Let's say they actually enter the correct password, ABC123. Says it's true, it's correct. What if they accidentally capitalize a character? Not the same. One with a capital A, the other one not with a capital A, not the same, so that's false. Lastly, if the person is an inexperienced coder and they accidentally forget that Mr. Foster was very clear and even did the X's with his hands that you're not supposed to compare strings with equals equals, even though they're a wonderful student, they still did it just because they were being a little bit absent-minded, not that they have any character flaws or anything. They do something like that. Well, let's see. We all agree that the password's ABC123, right? This is why you do not compare strings with equals equals. It compiles, it says it's legal code, but then it doesn't give you the result that you think you're going to get. So there's that. So basically, Boolean variables, true or false. We're going to be looking at them this unit because that's how the computer is going to make decisions. And you can get the computer to evaluate a Boolean expression using less than or equal to, greater than or equal to, equals to compare equality, exclamation point equals to compare inequality. And then if you want to compare strings, don't do equals to compare equality, use dot equals. Yeah, that's all I had. I can do one of the examples since we have a little bit of extra time. I know I said this is only going to take 15 minutes, but do you want me to do one of these like exercises? Why not? There's 3 of us. We're not going to tell anybody. Okay. If you got to go, that's fine too. 288. Let me do. Can I do this one real quick and then I'll do 288? Is that cool? Okay. I promise I'll go super quick and then I'll look at 288 because I'm feeling Carly might not have to look at 288, but we can do it. That's fine. So let me look at this one. 316, Austin 316. Okay, what am I supposed to do here? And you don't have to write this all down. I'm recording this thing. It's fine. Or you can take a picture of it when I'm done. It's fine too. With Boolean, it gave me a good answer. Interesting. Okay, we'll get there in a second. So let's see here. Ask the user to enter 2 ints. Create 3, so enter 2. Okay. I'm just going to make it look exactly like theirs. System.out looks like a println because down here in the prompt, it's on a separate line from where they actually enter their numbers. So maybe I'll do something like that. And, oh, you know what? I haven't even created a scanner, so I need to do that before I get any of the stuff. Has all this online school made you guys better typers? I don't know. Hopefully. They don't teach typing enough or anymore. I don't know if they think there's not going to be computers in your workplaces when you get older or what. Enter two numbers. Okay, so maybe I'll do int num1 equals input.nextInt. Int num2 equals input, dot next int. Okay, so there's two numbers. Compare the numbers as instructed. Create three. Okay, so here's the next part here. Create three Boolean variables as described below. The first should be true if the first number is less than the second number. So maybe Boolean less. First number should be the first number. The first number is less than the second number. The first number is less than the second number. The second should be true if the first is equal to the second number. First number equal to the second number. You know I'm putting two equal signs there for comparing. The third should be true if the first number is greater than the second number. And then print the expressions and the result. Okay. They want me to make it look like this. Now, again, these are examples. I have to use the variables values instead of just 10 and 12 for everything. So this is where it gets a little annoying. I'll say that, but it's totally doable. The value of num1 with a less than sign after it. The value of num2 with a colon after it and a space, it looks like, less. Now, honestly, that was a complicated line for me to write. Let me make sure it works before I move on. 10 is less than 12, that's true. Okay, and since it was a complicated line and the rest of the lines look pretty similar, oh, you know what, one of your teachers might have disabled the copy and paste. That was me, sorry. That's okay though, that's okay. Equals equals, num2, it's not because of either of you. I was having, let's just say, issues with others. Okay. And then the value of num1 with a greater than sign after it, the value of num2 with a colon after it, and great. All right, let's check this bad boy. Let's see how we did. No errors, no whammies. Okay, I type in two numbers, 50 and 75. These should all be printlns. I see it now. Sorry about that. Println, println, println. Let me run it one more time just to double check here. Enter two numbers, 50, 75. 50 is less than 75, that's true. 50 is equal to 75, that's false. 50 is greater than 75, that is false as well. If they enter different numbers, it'll evaluate them differently. 50 is less than 50 is false. 50 equals 50, that's true. 50 is greater than 50, that's false. So we're making these Boolean variables and having the computer evaluate them in 3.1, and then we'll be able to use them in decision making in 3.2. So that's kind of the idea. Did I pass all the tests? Let's go.